Hello students, welcome to this particular session on perception, which is a part of general psychology. So, the main objectives of this particular lesson are to understand what are perceptual constancies and what is depth perception, and in depth perception what are these monocular cues and binocular cues. Now, let us see what are perceptual constancies. Perceptual constancies play an important role in interpreting the information appropriately. Have you any time wondered why we tend to perceive the thing or a person as the same, even though it looks different on our retina? For example, if you are standing at your house entrance and you look towards your right and see a person coming and realize that it is your friend, even though the image on your retina is very small, but still you perceive him as the same person, isn't it? Regardless of the image on the retina, which is very small. It happens because of perceptual constancies. Hence, these are the tendencies to perceive aspects of the world as unchanging despite changes in the sensory input we receive from them. For example, seeing a relative walking towards you who is several yards away and still perceive him the same. Some objects which are far away, including trees, people, etc., which cast tiny images on your retina and help you perceive them as being of normal size. Therefore, some factors seem to account for this type of tendency. The principle of size distance invariance says that when accounting for the size of the object, we take into consideration both size of the image it casts on our retina and apparent distance of the object. Our perceptual experiences are not isolated, but are built in a world of identifiable things. A well-known object is perceived as permanent and stable regardless of the illumination on it and the position from which it is viewed, or you can say the tendency to see an object's shape as unchanging regardless of the viewing angle, are all examples of constancies. Even though the retinal image of a receding automobile you see on a road very far away shrinks in size, the normal experienced person perceives the size of the object to remain constant, and one of the most impressive features of perceiving is the tendency of objects to appear stable, their continually changing stimulus features. For example, if there is a dinner plate on a table in your particular room, the image on the retina undergoes considerable changes in terms of shape and size as the perceiver and the plate when it moves, and even with this the dinner plate does not change, does it? You still perceive it as a dinner plate even though you see it from different angles. Hence, when there is a stability in perception in spite of gross instability in stimulation, it is the object as it is perceived and the object as it is understood to actually exist, regardless of the transformations in the energy stimulation, and these are all called as perceptual constancies. The dimensions of visual experience which shows constancy include size, shape, brightness and color. Perceptual constancies tend to prevail for three dimensions as long as the observer has appropriate contextual cues. For example, perception of size constancy depends on the clues that allows one a valid assessment of his distance from the object, and with distance accurately perceived, the apparent size of an object tends to remain stable, especially for highly familiar objects that have a standard size. Thus, a person's head tends to look the same regardless of the distance and similarity of an object, which is again identified as a lump of coal tends to look black even when intensely it is illuminated. For example, a lump of coal if you put in a room and even though you have a light on it, you still perceive it as a coal. It is seen that there are individual differences in perceiving. Theoretical assertions about perceiving are often made as though they apply indiscriminately to all organisms or at least to all people. Perceptual principles of such great generality eventually will be uncovered in the particular meantime. It is evident that there are clear differences in perceptual functioning among individuals, among classes of individuals and within the same individual from one occasion to another. Coming to age, age tends to influence perceptual experience. The perceptual functioning should change with perceiver's age, is expected on the sounds that psychological development stems from particular learning and also the malnutrition. The empirical evidence for age related changes in perceiving is substantial. There are reliable data that perceptual constancies are enhanced with persons increasing age, improvement leveling off at about the age of 10. Similarly, there is a great deal of evidence for both decreased and increased susceptibility to various optical illusions with increased age. Those illusions which become less pronounced with increasing age probably depends on the subject's changes in terms of scanning and on his increased ability to segregate and see different parts of a pattern from one another. The evidence for perceptual learning is provided by investigating the effects of practice. For example, effects of practice on visual acuity were studied by requiring observers to detect simple orientation in a row of learning letters. There are different types of constancies. Let us talk about the first type of constancy, which we call it as size constancy. So, size constancy is the tendency to see an object as the same size regardless of the distance. It refers to the fact that as an object is moved farther away, we tend to see it as more or less invariant in size. For example, you hold a pencil in front of your eyes and one in your arm's length. Does it appear to get smaller? Not noticeably, so yet the retinal image of the quarter 12 inches, half the size of the image of the quarter when it is 24 inches from the eyes. It certainly does not appear to reduce to half its size as we move it to the arm length. Now, let us talk about shape constancy. It is a tendency to see an object shape as unchanging regardless of the viewing angle, which we call it as shape constancy. For example, when a door swings open towards us, its shape as projected on the retinal goes through a series of distortions from rectangle to trapezoid. We can readily distinguish these changes, but the psychological experience is unchanging, and the fact that the door does not seem to change its shape is a perfect example of shape constancy. Now, let us talk about color constancy. Familiar objects appear to retain their color under various lighting conditions, even colored light, which provide sufficient shadows and contrasts. Hence, the tendency to see the color for a familiar object as the same regardless of the actual light is called as color constancy. Without color constancy, the clues we see the color of the objects according to the wavelength of light being reflected to the particular eye. Although most of the research on perceptual constancies have focused on size, shape and brightness, constancies have every area of perception including our senses. Whatever their bases are, perceptual constancies are highly useful. Without them, we would spend a great deal of time and effort identifying sensory information into our environment, and each time we experience the information form a new perspective. Hence, the gap between our sensations and perceptions provided by the constancies is clearly beneficial. So, this was all about constancies and different types of constancies. Now, let us talk about depth perception, which is another aspect and an important aspect when we view things. Now, let us see what is depth perception. Did you ever try to wonder how you are able to cross a busy road without bumping into the vehicles, or how are you able to calculate the distance between the objects to take a particular decision? Well, the answer is because of having the depth perception. It is the ability to perceive the world in 3 dimensions and the distance of an object, and in this particular scenario our brain achieves it by processing different pictures from each eye and combining them to form a single 3D image. Depth perception makes it possible for your eyes to determine distances between objects and to tell if something is near to us or far away. Our ability to judge the depth and distance in terms of three-dimensional ways exists because we make use of many different cues forming such judgments. These cues can also be divided into two main categories called as monocular cues and binocular cues, which is again dependent on whether it can be seen with only one eye or it requires two eyes. Let's go deep into what exactly are monocular cues. Monocular cues are the ability to calculate depth by using only one eye. An artist, for example, is able to give more depth to his pictures because he can make use of many monocular cues, which tells us the distance of the objects. Although having two eyes helps us to perceive depth and distance, closing one eye causes some perception loss, but there is not much left to go, and some things are very better viewed with only one eye. For example, if you have gone to any exhibition and all, you have that shooting game where you use only one eye. So, that is a perfect example where you calculate distance by using only one eye. And these are all some of the pictures which you are seeing are different types of monocular cues by which we tend to calculate the depth perception. Size cues. The larger the size of the object on the retina, the larger it is judged to be. And if an object larger than other objects, it is often perceived as closer. That means anything larger is perceived to be close. The next is linear perspective. Parallel lines appear to converge in the distance. The greater this effect, the farther away an object appears to be. For example, try to observe the railway track. Those parallel lines, if you see from a great distance, it seems that they both unite. Next is the texture gradient. The texture of a surface appears smoother as distance increases. For example, if you see a wall from near, it does not appear smooth, but from a distance you tend to see it as a smooth surface. The next cue of monocular group is atmospheric perspective. The farther away the objects are, the less differently they are seen, such as smog, dust, haze, etc. Next is overlap or interposition. If one object overlaps other, it is seen as being closer than the one it covers. Next is aerial perspective. Objects which are far away seem to be blurred or slightly hazy due to the atmosphere. When we look off into the horizon, closer objects seems more distinct, while those in the distance might be obscured by the dust, fog or water, and this cue tells us that blurry objects tend to be farther away. The next concept is motion parallax. The perception of moving objects can also serve as a monocular cue for depth. For example, when we travel in a vehicle, objects far away appear to over in the same direction as the observer, whereas close objects move in the opposite direction and relatively fast, isn't it? So, next time when you sit in a vehicle or a train, just observe it. Objects at different distances appear to move at different velocities, and this provides us the cue to perceive the depth between the objects and calculate the distance. Now, as we have seen the monocular cues, let us talk about binocular cues. The cues which are taken in by two eyes are called binocular cues, and both the eyes play an important role in perceiving the depth. Binocular cues gives us the natural ability to determine where in space an object sits relative to our own body, and in this case our sense of depth perception enables us to know where to place our feet. Hence, we rely more on the binocular cues for depth perception or depth information, which is again based on coordinated efforts of both eyes. For example, in terms of depth perception comes from two sources, that is convergence and retinal disparity. Let us see what is this convergence and retinal disparity. Convergence. In order to see closer objects or images, our eyes turn inward toward one another, and the greater this movement, the closer such objects appear to be. So, in this particular picture also, the convergence of both eyes is different for different positions, as I said, in terms of far and near. For example, you can also try this at your home or at your college. Try to take a pencil and place it near to your eye and see how the eyes converge, and then the same pencil, try taking it little bit far away and see the difference, how your eyes are placed. Then you will understand this particular concept of convergence. The next is retinal disparity. It is also called as binocular parallax. Our eyes observe objects from slightly different position in space. The difference between these two images are interpreted by our brain to provide another cue for depth perception. For example, as you can see in this particular figure, there are trees over here, and if you tend to see the particular tree with one eye, closing the other eye, the angle would be different, and with closing the another eye and tend to see with the other remaining eye, the angle is different. So, the angle with each eye is completely different. It also refers to the small difference between the images projected on the two retinas when looking at an object or scene. This slight difference or disparity in retinal image serves as binocular cue for perception of depth. Retinal disparity happens in humans, and mostly it happens in higher vertebrates with two frontally directed eyes. By the separation of the eyes, which causes the eyes to have different angles of objects or scenes, and hence is the foundation for stereoscopic vision, which again refers to unified three-dimensional view of objects produced when two different images are fused into one. In short, it can also be said that the differences between the images received by the left eye and right eye as a result of viewing the world from slightly different angles. According to Schiffman, they have listed the monocular and binocular cues by no means of exhaustive, and by using the wealth of information provided by these and other cues, we can usually perceive depth and distance with a great accuracy. Sometimes we are not in a position to have depth perception because of possibility of having some conditions. So, let us look at some of the conditions by which we will not able to calculate depth or achieve the depth perception. The first condition is amblyopia. It is also called as lazy eye, and it is a condition where one eye is weaker than the other, and this usually happens because of abnormal vision development in the childhood, and it features decreased vision in one or both eyes. Then the next condition, we call it as optic nerve hypoplasia. This occurs when optic nerve, which usually sends visual signals from your eyes to brain, has incomplete development before birth and can result in partial or total vision and loss in children. Next, we call it as strabismus. It occurs when the eyes point in different directions, such as one pointing straight ahead and other pointing inward or down. Then we have blurry vision. Many conditions can cause the vision in one or both eyes to be blurry, as can trauma also to an eye, for example, due to medical conditions too, this can happen. The next is injury to one eye. Trauma or injury, we can say, can alter your vision either temporarily or permanently. Sometimes this particular lack of depth perception can impact our life in several ways. Like not having depth perception can affect one's ability to learn. It can cause problems driving and navigating roads. It can prevent an athlete from reaching their full potential. It can stop you from getting certain jobs that require good depth perception. Hence, to sum it up, we can say that to interpret the world better without confusion and not creating chaos, perceptual constancies, depth perception helps a lot in terms of decision making and interpreting situations. We just cannot imagine world without them, and hence they play a very important role in a person's life. Now, let's summarize what we have learnt. The tendencies to perceive aspects of the world as unchanging despite changes in the sensory input we receive from them are called perceptual constancies. The principle of size distance invariance says that when accounting for the size of the object, we take into consideration both size of the image it casts on a retina and apparent image. There are different kinds of perceptual constancies such as size, shape and color, and the ability to view the world in terms of three-dimensional ways in terms of depth and distance is called depth perception, and we do it by means of some cues we get in form of monocular cues and binocular cues. Monocular cues gives more depth when only one eye is used, such as artists who can give more depth to pictures, and in similar way many monocular cues can tell us the distance of the objects, but some things are more clear by using two eyes, which we call it as binocular cues, where vision of two eyes cooperate to yield the experience and perceive the depth.